Here we go. Today, by the end of this lesson, you'll be able to calculate various aspects of position, time, velocity of something in free fall and know the fun facts of free fall and how to apply them to help you solve problems. Okay, so when is something in free fall? When only the force of gravity is acting on an object. It isn't touching anything. Okay? But it's not touching anything. Vincent.
But like how do you describe that's what I the motion of free fall?
Okay, yep. Hold on to
It's
that.
falling down to the singular point of gravity.
Correct. Okay, so if gravity is the only thing acting on the object, it will move in such a way any object will experience, no, any, let's do it, every object will experience an acceleration of gravity of 9.8 meters per second squared downward. Okay. So acceleration is equal to negative 9.8 meters per second squared. Okay. You were kind of introduced to that yesterday or the past 2 days with the unfortunate skydiver. Okay. Gave you that number, 9.8, negative 9.8. Use that in your calculations. Okay, so talking about that, if I took our unfortunate skydiver and a piece of paper and I dropped it, you're probably not going to argue that about like, oh, skydiver, sure, whatever, but the paper, that certainly didn't experience an acceleration of 9.8 meters per second squared downward. Why not?
Because it's just slower, like it's like just
Yes, why?
air resistance.
Yes, you got air resistance. Okay? So if I were to take this piece of paper and I crumple it up, okay, drop it. All right. Okay, another experiment. I took a bowling ball and a golf ball and I dropped them. Which one's going to hit the ground first?
The golf ball. What?
Ready? 3, 2. Is he really going to do this? 1.
I was expecting a loud
I know you were.
boom, and the whole wing would just hear it. Like
Okay.
loud.
No.
This it sounded like this from
Dodge that bullet. All right. So is everybody good with that? Like, they both experience the same, independent of their mass. Does not matter how massive it is, how heavy it is. Good with that?
Yes.
Every object. Okay. Now, they did this cool experiment in the world's largest vacuum chamber. the ball and feather. Granted, they're like ostrich feathers, but look, the feathers won. Good at that. Okay. You get rid of air resistance. Every object falls at the same rate, 9.8 meters per second squared. Now, some people have issues with this, like, that's stupid. Like, that's not real life. Like, you can't just, air resistance gone.
Oh,
Okay.
look, there's air, oh, look, a vacuum, boosh,
Mhm.
fall into the void.
So,
You'll just keep accelerating until there is something that's slowing down.
right.
That's why in space you would get like burned alive when you enter atmosphere because you're going so fast,
Correct.
thanks to compression.
So, what we're gonna do, if you were to include air resistance, that's super crazy complicated. Like it's the last thing I teach my calculus-based physics students because it's so complicated. Like I have to teach them more math to be able to handle it. We're gonna ignore air resistance. You're welcome.
We're just gonna use random void-filled
Okay.
gravity wells.
So once we understand the simple, then we can add additional complexities on top of that. That make sense?
Yeah.
Okay, so we're ignoring air resistance. Give that one a shot.
So we just take out the atmosphere, or we just put a random gravity well, that's set mass.
Yeah, we just ignore it. So for these so for multiple choice questions in this class, like just like for lecture time, we're gonna round 9.8 to 10. Just makes the mental math easier.
I like
But
your
when you
28.
do labs, when you do homework, when you do tests, negative 9.8. Okay, but for just the mental mathing,
I'd rather
round that
deal
to
with
10.
I'd rather deal with 9.8.
Tell your neighbor. Tell them why. Explain it.
So it's Amy.
Correct answer is D. Every second that goes by, you change your velocity by 10 meters per second. 0, 10 meters a second, 20 meters a second, 30 meters a second, 40 meters a second, 50 meters a second. Good?
And basically you're increasing speed as you go on.
Exactly. All right. Okay. Conversation.
Just about.
In this case, would be
Educated guess, use 10.
But if you like, what if I said this to the end?
Hold on.
Around 30.
How far?
Oh, like for the last question.
Oh, I asked how fast. So it's speed, just the magnitude of velocity. Okay, let's see if you're right. So, you drop a rock Takes 3 seconds. So that's my delta t. Okay? If an object is experiencing acceleration, what equations can I use? I can use any of these kinematic equations. So in free fall, this is a special case of a scenario where you can use kinematic equations. Okay? Now, it's a little, this one's kind of odd because I only gave you one number. But if you can discern, like, oh, it's in free fall, then you know acceleration is equal to negative 9.8 meters per second squared. Okay? You will, on the test, I will give you these equations. You will need to memorize this. It's in your brain already. Okay? And you're going to use it enough. But the important thing is knowing when this is true and when it's not. Okay? So, if you dropped something, we drop something, it starts at rest. Your initial velocity is equal to 0. Okay. So I'm looking for the rock's displacement. So I want you to pick, by yourself in your own brain, which of those 4 kinematic equations am I going to use for this problem, to solve this problem. Do not influence or be influenced. Thumbs up when you have an answer. Show me number of fingers, 1, 2, 3, or 4. Which equation are you going to use? Correct answer is 3. Okay, this has all 4 of the things that we're looking for. Okay, so we go displacement is equal to initial velocity times time plus 1/2 acceleration times time squared. Displacement is equal to, this goes to 0 because your initial velocity is 0. So you have 1/2 times negative 9.8 meters per second squared times 3 seconds. The squared is only applied to the 3, not to the 9.8 or the half. Okay? I'm just going to write this out in full detail just so that I'm trying to teach you. Okay? And that's going to be, should be around, that was 44.1, I think, meters. Yeah. And it's negative, which means what? Downward. Yep. In negative direction. Good with that? Okay. How do we do? Previous question? Is this in the realm of reality? Sure. Have a football field, 3 seconds. Like falling for 3 seconds, 1 Mississippi, 2 Mississippi, 3 Mississippi. I mean, that's a long way to fall. Good? So you can calculate how, quick little mental math, you can figure out how high you are on like a bridge or something by dropping a rock, counting or timing it. And like round that to 10. So that's like 5 times whatever this time squared is, meters. And then multiply that by 3 to figure out feet, roughly. Okay? Correct answer is the condition for free fall is if the object isn't touching anything and the only force acting on it is gravity. That is true, even if it's going up. So yes, it's considered free fall. Good? Okay. So don't let that throw you, like, it's going up, that's not falling, and it's considered free fall, okay? Here are some memorized facts that you need to know that are very helpful. I call them the fun facts of free fall. There's 3 of them, okay? The time up is equal to the time down. So long as you throw it and catch it at the same height, time up equals time down. If I did this, that would not be. If I catch it and throw it at different heights, that doesn't work. But if you catch it and throw it at the same height, the time up equals the time down. Okay? First fun fact of free fall. Second fun fact of free fall. Whatever speed I threw it at, if I catch it at the same height, it's going to have that same speed just going downward. So the velocity up equals the negative velocity down. Okay, so if I throw it up at 20 meters a second, it's going to hit my hand going 20 meters a second. Okay, right here, at some elevated, if it passes my hand going 5 meters a second, it's going to pass. Sorry, it's going to pass my finger moving 5 meters a second on the way down. Okay, velocity up equals the velocity down. Good. Last fun fact: free fall. Tell your neighbor.
Oh. Talking about highest point, really?
Yeah. Like
How fast was the truck going at the highest point?
0.
0. So at the apex, at the peak.
But like, free fall could be going up,
Yeah.
or going down.
Right. So like at the high. So if you dropped at the highest points here, if you threw it up, the highest points is. You okay with that? Have you ever been on some elevated position, a ladder, a tree house, a roof, and someone's thrown something up to you and it's been like a perfect throw? The object's like, oh, thank you. And you just like snatch it out of the air. You're like, wow, that is so cool. Try it. Okay? So, the highest point is going 0 meters a second. Those are your fun facts of free fall. Rarely do I tell you to memorize stuff. Those are
It's just my these are on my slide.
yeah.
Thank you. Thank you.
Okay. All right. So, identify your variables for this scenario. Tell the neighbor.
It's initial or right from Oh, no, but it went at times. Because it was already at a times 20, yeah.
Okay, what do you say? Okay, let's look it on the way up. Something is in free fall if only the force of gravity is acting on it, meaning it's not touching anything. If it's in the barrel of the gun, it is touching something. That is not free fall. Okay? When it is left the barrel of the gun, it is moving at 22 meters a second. Similarly, on the way back down, if that's touching something, that's not free fall. So it's right before it hits your head. Moving. Correct answer is D, dangerous dinosaurs. Everybody, this is a really important skill. Recognize when you're setting up your variables, when to say start and when to say stop. Does that make sense? Not in the gun, not splatted on your head. Okay? All right, so an arrow is shot straight up. At its highest point, it reaches a height of 70 meters. Assuming it's shot from the ground, how fast was it shot out of the bow? So what I want you to do is not necessarily find the answer, but I want you to set it up, identify your variables, and maybe even pick an equation. I'll give you a minute head start, and then I'll show you how to do it. So I'm gonna make my initial point down here. I'm gonna make my final point up top. I know it doesn't stop there, but just like our fan cart, you can pick any two places along that path to be your initial and your final. You okay with that? I know stuff about my final, so that's why I'm gonna pick it. Okay, so I know I have a displacement of 70 meters. Okay? It's in free fall. Okay? I'm looking for how fast it's going. I need one more piece of information. Is what? How do you know that? At the highest point, your final velocity is 0 at the highest point. Good with that?
Yeah.
Okay. So, here's our variables. pick which kinematic equation we're gonna use. Show me 1, 2, 3, or 4. Which one am I gonna use? We're getting better at this.
Yeah.
Correct answer is 4. Fourth equation, it does not have time, but it has all the ones we're looking for. So I have final velocity squared is equal to initial velocity squared plus 2 times acceleration times displacement. So my final velocity is 0, my initial velocity I'm looking for, 2 times negative 9.8 meters per second squared times 70 meters. That's just my You're welcome. Was it 13? What was it? 1392? 72. 72. Thank you. 1372. Bring that over. Take the square root.
We don't need to do plus or minus, right?
So that was 34.1. Is that right?
And it's 0,
What?
0, 4. It's not like entirely 1.
Okay, we'll just say 34 meters a second. Okay, now. So, when you take the square root in math, technically, what's the answer? Plus or minus. Which one are we going to choose for this scenario?
Plus.
Why plus?
It's going up.
It's going up.
Why is it 34? I did the math.
I don't know. I'm going off
It's like
of.
37.
Is it 30?
Square root of the number.
Sure, 37.
Yeah.
Sorry, it's going off of memory. So upward. Okay. Now, is this in the realm of possibilities? 37 meters a second. To like match that with miles an hour, convert that to miles an hour, roughly multiply by 2. Technically, it's multiplied by 2.45, but like, yeah, 70 miles an hour. Ish. That in the realm of possibilities. An arrow coming out of a bow.
No.
Yeah. It's pretty fast. You okay with that? Like, so.
Why is it in free fall when it's like shot out of a bow, but the cannon isn't in free fall?
It was in free fall.
Oh, it was.
It was. Yeah, it was in free fall. Because only after it leaves the bow, after it leaves the cannon.
Oh, wait, but it's paint.
Paintball is also after it leaves the
So why does
Great
the
question.
force from like the paint gun or like the shot or the cannon not count as force?
It is, but after it leaves, you no longer.
Isn't the definition of the force acting as gravity?
Yeah, hang on. I've got a question for you. Specifically hitting that towards the end. It's a great question. All right, everybody good? Actually, this. Okay, give this one a shot. Tell your neighbor.
Oh.
Yeah, but you have to do
Correct answer is? Correct answer is A. Okay, check this out. The moment it leaves your hand, what forces are acting on it? Gravity? Anything else? We're ignoring air resistance.
Who said that right up?
Hold on, Vincent. Okay. The moment it leaves your hand, nothing else is acting on it other than gravity. It would be really cool if I could exert a force on it without touching it. Okay? Like Jedi. Not gonna happen here in physics. Good? Okay? The moment it leaves your hand, gravity's action on it, causing it to speed up, slow down, what? Starts to slow down, like it's acting in the opposite direction of motion. So this is the fastest it's gonna go. Good for that? That get your question. So there's no, after it leaves the cannon, after it leaves the bow, there's no force from the bow or the cannon or your hand once contact is removed. Okay? Tell your neighbor. Correct answer is B. Okay? As it goes up, what's the direction of velocity? Positive. What's it doing as it goes up? Speeding up or slowing down? Slowing down. Therefore, acceleration is in the opposite direction of velocity. Which way is the force of gravity acting on the ball? Downward. Therefore, the acceleration is also downward. Force causes acceleration. On the way back down, direction of acceleration. Tell your neighbor. Tell him why.
It's negative because the force is still pushing downwards. That's why it's in switch direction. It's good.
Gravity pulls up, you see the left.
Correct answer is still B. Okay? As it's falling, what's the direction of velocity? Negative. Downward. What's it doing? Speeding up, slowing down? Speeding up. Therefore, the direction of acceleration is in the same direction as the velocity, downward. What's the direction of the force? Still downward. Acceleration, downward. Last question. Correct answer.
See,
Okay, here we go. Ready? How fast is it going at the highest point? Zero. Right? For how long is it going 0 meters per second? Just a moment, an instant in time. The moment right beforehand, is it moving? Yes. The moment right afterwards, is it moving? Yes. So from moment to moment to moment, is velocity changing? Yes. Therefore, you have acceleration. Did the force of gravity like, nope, can't act on you, you're at the highest point, I'm gonna turn off? That's absurd. Okay? Okay, so always acceleration. All right, you got a worksheet, I actually printed it off up here.